All right, let's dive in. You know those time and work problems you see on exams? It can look super tricky, right? Well, guess what? They all run on the exact same simple logic, and today we're going to map it out together.
I mean, really think about it. This isn't just some random math problem. It's something you actually deal with. Project management. The exact same thinking you'd use to plan a big project, that's what we're going to use to solve these questions.
Okay, so first things first, let's break this whole thing down to its absolute bare bones. Every single one of these problems, I don't care how they word it, is just a mix of a few core things.
Yep, that's it. These are literally the only three things you ever need to keep track of. How long you've got, how much work needs to be done, and how many people are on the job. Everything else, the whole puzzle, is just built on how these three things play together.
And the way they relate to each other? It's just common sense, really. You add more people, what happens? You get more stuff done in the same amount of time. Makes sense, right? That's what we call directly proportional. Now, on the flip side, you add more people to the same task, the time it takes just drops. That's inversely proportional. See? Simple.
All right, now for the secret sauce. This next part is the single most important idea for nailing these problems. It's what connects time to the actual work getting done. Think of it as your problem-solving superpower, efficiency. So, what is efficiency in this context? It's really just a number, a percentage, that tells you how fast someone works. It's kind of like their daily productivity score. The bigger the percentage, the quicker they are.
And figuring it out is super easy. It's just a simple two-step recipe. First, you turn the time into a fraction. Like, if someone takes 5 days to do a job, they're doing 1/5 of it each day. Then, step 2, you just multiply that by 100 to get your percentage. So 1/5 becomes, boom, 20% efficiency.
And you can see the pattern really clearly here. Somebody who finishes a job in just 2 days, they've got a massive 50% daily efficiency. But someone who takes 10 days, theirs is only 10%. The rule is just dead simple. The less time it takes, the higher that efficiency score.
Okay, so we've got our ingredients, time, work, and now our superpower, efficiency. So, how do we put it all together? Well, we're going to use this amazing visual tool, a kind of blueprint or a mind map that lays it all out and shows you the path to the right answer every time.
And here it is. This is the blueprint. Look at how it's organized. On the left, you've got your people and the time they take. In the middle, that's where we'll crunch the numbers for their efficiency. And over on the right, we define the total amount of work. Trust me, this structure is the key. It keeps everything neat and tidy.
All right, enough talk. Let's put this blueprint to work. We're going to take a classic time and work problem, and you'll see just how powerful this visual method really is.
Okay, so here's our challenge problem. A does a work in 10 days, and B does the same work in 15 days. In how many days they together will do the same work? So you've got two people, different speeds, how fast can they get it done as a team? This is exactly what our blueprint was made for.
Let's start plugging things into our blueprint. First up, we need to define the total work. The easiest way to do this is to find a number that both 10 and 15 go into nicely, the least common multiple, or LCM. For 10 and 15, that's 30. So let's just say the project is 30 units of work. Now we can find their efficiency. If A does 30 units in 10 days, they're doing 3 units a day. And B? They do 30 units in 15 days, so their efficiency is 2 units a day. See how that works?
Okay, so now they're teaming up. What do? We just add their individual power levels together. A's 3 units per day plus B's 2 units per day. That gives us a combined team efficiency of 5 units of work every single day they're on the job.
And now for the final super satisfying step. You just divide the total work by their combined efficiency. We've got 30 units of work to do, and the team is knocking out 5 units a day. So 30 divided by 5 is 6. 6 days. That's our answer. The blueprint just turned a confusing word problem into simple math.
And you know what's cool? The same logic works even when you have things working against each other. Think about a pipe filling a tank. That's positive work, right? But what if there's a leak draining it at the same time? That's just negative work. You just subtract the leak's work rate from the pipe's fill rate. Same idea.
And this blueprint is really flexible. It's not just a one-way street. You can actually work backwards with it. Say you know how long it took a team to finish, and you know one person's individual time. You can use the same map to figure out the other person's speed. It's awesome.
So, okay, we've totally cracked the code for these exam questions. But this way of thinking, this idea of breaking a big goal into smaller units and then measuring your speed, That's a seriously powerful tool for planning pretty much anything in your life.
So let's just do a quick recap of the whole strategy. Number 1, always break the problem down into those 3 core parts: time, work, and people. Number 2, remember that efficiency is the secret ingredient that connects them all. 3, use that visual blueprint to map everything out so you don't get lost. And 4, you add efficiencies when people team up, and you subtract when something is working against you. And that's the whole game plan right there.
And that brings us to one last thought. This is about more than just passing a test, right? This is a mental model for getting things done. So the real question is, how could you use this efficiency blueprint to plan out your next big project? How could it help you reach your own goals faster?